problems with graphing that you're noticing? Are we making a lot of mistakes with graphing? Yeah, okay, so students tend to make a lot of mistakes with graphing. Maybe when you're graphing your lines, it's not perfect to see where they intersect. It isn't the most exact way. What if solutions are really, really large? Then are you going to be graphing the point 20, 25? That would be really difficult, okay? So we're going to talk about how are some ways with solving that we can find things other than graphing. Still finding solutions, just a different way. Substitution. In class on Friday, I mentioned when you play sports and you're on a team, how does substitution work? Somebody comes out, right, and somebody goes in place of them, okay? So the idea with substitution is we're going to take a variable out, and in place of it, we're going to put a different expression with the other variable in it. When is it best to use substitution? When one of the variables is alone. I'll say isolated by itself. Okay, for example, if I had A equals 7 plus 3B, and then I told you A plus B equals 12. So if I gave you a system like that, what's the variable that's isolated or alone? There's one variable that's all alone on one of the sides of the equations in one of them. Can you pick it out? It's A, yes. That A right there is isolated. And so what substitution would mean, like, hey, oh, A, I can take an A out and I can replace it with the expression 7 plus 3B. We're going to do the substitution in a minute. Another time when you're going to want to use substitution is even if you have both variables alone. So y equals 2x minus 1 and y equals negative 1x plus 8, for instance. Okay. Do you see in this case, both of them are alone? So you have a choice. You can either take this y and replace 2x minus 1 down here, or you can go up there. So sometimes you have a choice if both variables are alone. Okay. Let's do one. Let's look at example 1. So in both example ones, both of the y's in example 1 are alone. And so this is one like that second one I just showed you. Y is equal to 2x plus 2. So what we're going to do is, do you see this y down here? We're going to take it out. It's going to come out. In its place, we're going to put what y is equal to in that spot. What is y equal to? 2x plus 2, right? So I'm going to write, in the place of y, it came out, 2x plus 2, and I'm going to say equals negative 3x plus 4. Question, Ben?
When we solve it, do we write them as x equals and y equals, or is it an ordered pair?
Either is fine. Either is fine. Just don't forget what we learned about graphing. Just know that it is an ordered pair, and it would be where they would meet if you were to graph them. All right, here's what I want you to do. Would you solve for x, please? And then check your answer with somebody around you. Okay, I'm going to give you 20 seconds to talk or just look at, kind of show each other your papers. Keenan, did you get a chance to check with somebody? Yeah. Can you tell me what you guys got? So it is already -3, so to move it, I added it to both sides, okay? Okay, I'm going ahead and finishing. Is this making sense what I'm doing? Okay, so 5x equals 2/5. You can go ahead if you want and write it as a decimal, which is what? 0.4. Very nice. Okay, Ben kind of alluded to this a minute ago, but he said when you find x and y, so what he's telling me is he understood I found x, but what's the other variable? Y. So I do have to go back and find it. Look up here. You're given two equations for y. Either one, because this is going to work in both, you may plug in a 0.4 for x. Let's do it. I'm going to do that up at the first one. So y equals 2 times x. I'm going to write 2 times 0.4 plus 2. Would you calculate that for me, please? Did you get 2.8? Okay. So, two choices. You can leave it as long as I can see what your x and y is, or you can write it as an ordered pair, because really what this means is if you were to graph those two lines, that is where they would meet. If you graphed those two lines, would you be able to tell a 0.4 and a 2.8 on the graph? No. This is another reason why other methods are more accurate. Okay. Let's see. Let's do example 4. What variable is alone in example 4? M. Would you kind of put a box around M or highlight it? Would you find the M in the other equation and put a box around that? Just the M. What is happening to M in the bottom equation? What's in front of it? 3. So when we do our substitution on this one, we got to keep that 3 in front of our new expression for M. Okay, we're ready to substitute. M is coming out. What are we going to put in place of M? 5n. So I rewrite the bottom equation. Don't forget this. I'm dropping everything down. I have 5n plus 3, that's that 3. In M spot, I like to always hold it with the parentheses. I am going to put what M equals from up here, which was a 5n equals 0. Okay, 3n or 5n plus 3 times 5n. What do I get when I add those together? 15n plus 5n. 20n equals 0. Would you divide both sides by 20? Maybe you don't even need to. What does n equal? 0. 0 is a number. Think of 0 on the ordered plane or coordinate plane. 0 is the middle, okay? What happens when you plug it in for? You get 0. Up here, we plug it in and we say m equals 5 times what n equals. M also equals 0. That's okay. Don't get confused by that. It's like if you were graphing and they met in the middle at 0, comma, 0. Okay. What I would like you to do is, I don't want you to solve. I would like you to try the substitution in question 3 a minute on your own. So you're going to be substituting for L. Would you just try the substitution? Check with somebody, would you? Check with somebody next to you, or maybe if you're stuck, ask me a question. Okay, what I'm seeing, I saw, checked in with some of you. L equals 2 plus 4W. This came out, and I was really glad I saw a lot of people left that 2 in front. 2 times 2 plus 4W plus 2W equals 84. Okay, let's keep going. What would I do now? Multiply. Distribute, right? 4 plus 8W plus 2W equals 84. Put these together. Don't try to move them. They're all on the same side already, right? What's 8W plus 2W? 10W. And are we cool with moving this 4 to the other side? All right, so we get 10W equals 80. Divide by 10. W equals 8. Would you go find L a minute for me? Up here, I'm going to take out the W and I'm going to put an 8 in its spot up here. So I write L equals 2 plus 4 times 8. And was that you, Ben, who said 34? L equals 34. Okay. Let's do a couple of these. These are kind of PSAT-ish, okay? Sometimes instead of just a variable alone, you can get an expression alone. Do you see here how there's m over n? Do you also see that same m over n right there? What does m over n equal? 3. So I could take this m over n right here out and put what in its spot? 3, but there's a 5 in front. So this would be 5 times 3. The value of that would just be 15. Okay. 6. In this one, oh, same thing, A over B. Shoot, do I see an A over B in the other problem? No. So on this one, what I'm going to do is I'm going to multiply both sides by B. Now I have A equals 8B. What could I do in the bottom equation with that? Take out 8. Sorry, take out A and replace it with 8B. Do you see how then you could solve for B and you'd have an equation? Okay. What next? Good. So I minus 3, I get negative 6 equals 5B. Divide by 5. And just leave it. The question only asked for this one. It didn't ask for A, it just asked what's the value of B.